Hopefully it works. Okay, so we're going to talk about imaginary numbers today. Alright, so you have to know a pattern of I. So remember that I is equal to the square root of -1. But we don't write the square root of -1, we just write I. That means that I squared is equal to the square root of -1 times the square root of -1, which that would just give us -1. I cubed is the same if we broke down this to I squared times I, correct? We know that I squared is -1 and I is just I, so then I cubed must be -I. And then finally we have I to the 4th, which is like I squared times I squared, which wouldn't that give us -1 times -1? So therefore I to the 4th is equal to 1. You could keep going on and on and on like this. However, you only need to know these first 4. So if you know this pattern, I to the 1st is equal to I squared is equal to -1, I cubed is equal to -I, and I to the 4th is equal to 1, then you know all you need to know about I. Just about. Right? So, there's a stupid sentence that goes with this. And if you cannot remember this pattern, maybe you can remember this dumb sentence. So, it goes like this. I won with negatives in the middle. If you just read the sentence, it makes absolutely 0 sense. Okay? But if you look at the pattern of I, it goes like this. I won with negatives in the middle. Totally dumb. But if you can't remember the pattern, remember the stupid sentence. Sound good? Okay? It's stupid. It doesn't matter. Okay? Moving on. I am recording this. I shouldn't say stupid. I'm sorry. Alright. The next thing let's talk about is what a complex number looks like. So a complex number looks like A plus B times I, where A is the real number and B is the imaginary. Okay. You have to write your complex numbers like this. Like, you can't switch the order. They have to be in this format, A plus B, I. You know I'm going to mark you down if you don't, okay? So make sure you write it in this format. All right, so let's do some examples. Let's say, for example 1, I was asked to simplify. And I was given I to the 6th.
Is it always lowercase?
Yeah, it's always lowercase I. What's I to the 6th equal to? Remember that pattern? I won with negatives in the middle. Okay? How can you figure that out? You think it's -1?
Yeah.
How come?
Going.
If you keep going, anyone break it down? This is like I to the 4th times I squared, right? Well, what's I to the 4th equal to? 1. And what is I squared equal to? -1. So this must be -1. Okay, what if I gave you I to the 21st? -I. Maybe. Maybe not. What could it be? Think about the pattern. I'm not giving you the answer, so we're gonna be sitting here for a while. This video is gonna get awkward. It's just I. Okay, I'll go with it's just I. It is I, but why?
Because
20 and 1. So then you're kind of thinking of this like I to the 20th times I to the 1st, because those add together to give you 21, right? And then this I to the 20th, isn't that kind of like thinking I to the 4th raised to the 5th power like 5 times, right? Because remember, we just multiply those exponents. So I to the 4th is 1, and 1 times itself 5 times gives you 1. So none of this really matters. The only thing that matters is this I to the 1st power. That's why our answer is I. What about this one? I to the 1003. Making it more exciting now. What do you got to do here? Negative I? I agree. How come?
Because if you just do like 1,000, it would be I, and then like the 3 is.
So, like, there's I to the 4th occurring 250 times here, right? Because 4 times 250 gives you 1,000 times I cubed. Well, none of that matters because this is equal to 1, so this is just I cubed, which is negative I. Now, let me show you what we're really doing here. Okay, so now I'm going to give you the trick. All you have to do is take the numerator, or not the numerator, I'm sorry. All you have to do is take the exponent and divide it by 4. Because what you're really trying to determine is how many times does I to the 4th go into this, right? So if I take 1,003 and I divide it by 4, that is equal to 250 and 3/4. This 3 is the only piece I care about. Because the 250 represents I to the 4th times itself 250 times. The 3 represents this I cubed. I cubed is negative I. So go back to this one. If you had 21 and you divided it by 4, then you got 5 and 1/4. The remainder is what we care about. The remainder is 1. I to the 1st is I. Go back to this simple one. 6 divided by 4 gives us 1 and 2/4. 2 is our remainder. That gave us I squared. I squared is equal to negative 1. So if I give you a problem like I to the 32, what do you have to do? Take 32, divide it by 4, you get 8. Is there a remainder? So what does that mean? It means it's 1. So this is like I to the 4th times itself 8 times. Or, because there's no remainder, it's like I to the 0. Well, what's anything to the 0 power? 1. Okay, so you can think about it either way there. Do you understand the trick?
So you divide?
You divide by 4, and then you look at the remainder. We doing okay so far? Okay. Example 2. We are going to solve for A and B. Okay? So let's say we were given A plus 3 plus B minus 2i equals 7 plus 4i. Okay, now this problem looks complicated. We have like 3 letters going on here, but remember that I is not a variable. It's a number. It represents the square root of a negative 1, okay? So the only thing we care about is this A and B. Also remember that I told you that a complex number looks like A plus BI, where A is the real and B is the imaginary. So that must mean that these pieces that are real have to be equal to each other, and these pieces that are imaginary have to be equal to each other in order for these complex numbers to be equal to one another, okay? So you're going to take A plus 3 and set it equal to 7, and you're going to take B minus 2 and set it equal to 4. So A is 4 and B is 6. It's that easy, okay? There's a lot of problems like this in your homework, so make sure you refer to this. All right, so ready to get to the bulk of what we're doing? Yeah.
So that's all we have to do?
That's it.
We don't have to put it in?
Nope. Because it would just say 7 plus 4i equals 7 plus 4i if we plugged it in. Okay, so now this is really like the meat of the lesson. Okay, so simplify is our direction here. And let's start out easy. Let's say we're given the square root of a negative 9. If you're given the square root of a negative 9, you can do nothing with that right now because there's a negative root, right? But we know that this is like saying the square root of negative 1 times the square root of 9, isn't it? What's the square root of 9? 3. And what's the square root of negative 1? I. You don't have plus or minus here. You just assume the positive root. Okay? The only time we're going to get plus or minus out front is when you're solving for a variable. Okay? So that's it. 3i is our answer. What if you had this? 3 minus 2i plus negative 4 minus I. Do the parentheses matter? No, they're really just there to trick you. So get rid of them. 3 minus 2i minus 4 minus I. And then it's really just a matter of combining like terms. You can combine the real pieces, you combine the imaginary pieces, and you're all set. So we're going to get negative 1 minus 3i. Everybody okay on that? Okay. How about this one? Negative 3i squared plus I. What is I squared equal to? Negative 1. Every single time you see an I squared, it's negative 1. So this really means positive 3, doesn't it? Right? Which I don't know why I wrote that positive, but I did, so I got to rewrite it. So this is equal to 3 plus I.
So everything you see like the equivalent of 4 i's, can you substitute whatever?
Yes, every single time you see a pattern, you have to substitute in with I, I squared, I cubed, I to the fourth. Yes. Square root of negative 5 times the square root of negative 6. How many people say a square root of 30? Thank you for being honest. I know you're out there. I know there's a lot more of you out there. So easy, just multiply them together. Why not? That's what we do with square root of 2 times square root of 3. Get square root of 8. Why can't you do that here? Because you have to deal with those i's, right? Like you can't work with this until you deal with the fact that there's an imaginary number here. So as tempting as it is to multiply them together right now, you can't. So this really means the square root of 5i times the square root of 6i. This gives us the square root of 30 times I squared. But what is I squared? Negative 1. So I get negative root 30. See the difference between multiplying them at the beginning and doing it correctly. Okay, you got to deal with the I first. All right, how about 6 minus 2i times 2 minus 3i? What do we have to do here? You got to FOIL, right? You got two binomials being multiplied together. You have to FOIL these out. So we get 12 minus 4i minus 18i plus 6i squared. What's that 6i squared equal to? Like a minus 6, correct? Right? Because I squared is negative 1, so that's really like saying minus 6 there. Combine your like terms, you're going to get 6 minus 22i. Negative 5 over I. What's the issue here? Why do I got to do anything to this? Yeah, it's like there's a root in the denominator, right? Like we can't have that. You're not allowed to have a square root in the denominator, so what do you have to do? You're multiplying it by itself, right? Because that's what we do when we, starts with the R, Rationalize. We got to rationalize this, and in order to do that, you multiply by I. So this is going to give us negative 5i over I squared. But I squared is equal to negative 1. So this gives us 5i. Almost done. Can I move this? Okay, G. 3 minus 2i over 4 minus I. So we still have an issue. We still have an I in the denominator, but now we can't just multiply by I because then we just introduce a 4i. So what? Yes, the conjugate. Remember that? So 4 plus I is what we want to multiply by. Remember, to find the conjugate, all you do is you take the first and the last term, you keep those as is, and you change the middle sign. So now we got to FOIL this out in the numerator and the denominator. So we get 12 minus 8i plus 3i minus 2i squared over, in the denominator this becomes a difference of perfect squares. So we're going to get 16 minus I squared, right? I squared's like negative 1. So this is really saying 16 plus 1 down here. In the numerator, we have minus 2i squared. That's like saying plus 2. We're going to combine our like terms. This is going to get, whoopsie. This is going to give us 14 minus 5i over 17. You cannot leave your answer like this. You don't have a real and an imaginary separated. So we got to split this. So we're going to have 14 over 17 minus 5 over 17, and then the I goes next to it. If you don't write it like this, it's minus a half. Okay? You have to be able to see the real piece and the imaginary piece separated. Last problem. What if I started with 1 over 2 plus 3i squared? So I can't start out by multiplying by the conjugate anymore, can I? Right? I got to deal with the fact that this is squared first. So what should I do? FOIL it out or expand it. So 2 plus 3i times 2 plus 3i. This is going to give me 1 over 4 plus 12i plus 9i squared. Which that is like negative 9. Right? So in the denominator, I really have a minus 5 plus 12i. Now I'm kind of like in the same position I was in the last problem, right? What do I have to multiply by? The conjugate, which is going to be negative 5 minus 12i. So distribute that. In the denominator, you created the difference of perfect squares. If you cannot get the I to cancel, it means you did not multiply by the conjugate. You need to start over. Okay? So this is going to give us 25 minus 144i squared, which is really like 24 plus 144. I mean 25 plus 144. So negative 5 minus 12i over 169. But what do you have to do? Split it. So once you split it, you would want to double check to make sure your fractions don't simplify. They don't in this case. That's imaginary numbers.